Hello everyone, my name is Khosrow Moossavi. I'm going to present integration of Cloudstack with HashiCorp Vault today. So as term of agenda, I'm going to, since this is a very first integration between these two softwares, I'm going to talk a little bit about the Vault itself, what it does, why is it useful to have a Vault in the infrastructure, and a little bit of basic introduction about the Vault, different components in the Vault itself. And then I'm going to go back to the Cloudstack and describe the different integration points that we already have in place, such as VPN IP2 that has been mentioned a couple of times throughout the keynotes and such. And the second one is secure and hidden configuration that currently exists in the Cloudstack. It's going to be handled different way as it is now at the moment. And at the end, I'm going to describe what's coming, what should be coming next, what are the other enhancement points that can be feasible to look at or start implementing. So a little bit about myself. I'm a cloud infrastructure DevOps at CloudOps, working at Cloud.ca infrastructure. I've been part of the Cloudstack community since November last year. At the same time, I joined the CloudOps company. So I'm a relatively new member of the community. So about the Vault itself. I wonder how to make it. Anyway. So what Vault does, essentially, it stores and secures and tightly controls access to different type of things that's supposed to be secure or sensitive, or it has a sensitive nature, such as tokens, password, certificates, API keys, credential to the database, anything that considered to be sensitive to your business or your infrastructure. Vault can store them and can have access, can have defined and granularly defined access control to those different type of sensitive data. It also handles leasing, key revocation, key rotation, all those kind of stuff that most of the time, if you are going to do it yourself, it takes time. Vault has a capability out of the box to support that and handles that. It's part of the whole workflow and process inside the Vault itself. It also, one of the important and good functionality from the Vault, it has encryption and decryption of the data or whatever sensitive information on the fly without storing them. So you can, you have a, let's say, password. You can ask Vault to encrypt it, give it back without storing it anywhere in its backend storage. You can do whatever you want with that encrypted value, such as storing it in a database, store that in a Redis or whatever. And if the time comes that you need to access the actual value of that encrypted value, you grab that again, say from a simple database query, give it back to Vault, ask it to decrypt it, and it gives you back the actual unencrypted value. There's a gotcha point here, which I'm going to discuss a little bit later in the following slides. So I guess it's pretty obvious why Vault is useful, because we need to secure our data. That's the thing. It's one set of tool that is specifically designed for storing and managing the secrets. So it means that we as a developer or operations, we don't need to think about it or implement it. There is actually a piece of software with a whole community around it that does that for us. So it's a good thing to actually, for us to take leverage of the existing tool. It's open source, it's part of the Mozilla public license, and it has a very, very active community around it. It's backed by HashiCorp, but the community is really active. And there is another important part here that we should use Vault for basically everything, not the Cloudstack integration itself. So I don't know by show of hand who uses Vault in some shape of the form. So not a lot. It's not an integration point only for Cloudstack. We have secrets and password and sensitive data all over our infrastructure. It doesn't matter if you are on the development side or CI/CD, provisioning infrastructure, running application. So we as developers or an operation that manage the whole infrastructure or on different stacks of the infrastructure, we need to have a Vault cluster. Some part of the organization might use the same Vault for integration with the Chef Ansible to provision their infrastructure. Another part of the organization might use the same Vault cluster for the CI/CD pipeline to provision and actually deploy on production, staging, whatever infrastructure, or eventually the end application, the application stack can talk to Vault to do some kind of secret management. Cloudstack by its own is an application, is a web application. It does something on an infrastructure level, but at the end of the day, it's a web application. So it can use Vault to do all sorts of the secret management. So it is Vault is a really useful tool, and the integration of that to any piece of application or infrastructure pieces is a good thing to have anyway at the end of the day. I'm not going to go through all the details around here. If I can. So this is the high-level architecture of the Vault. There are a couple of parts that is important. It's fully API-driven with the REST API. It has extensive list of REST API that can be used with all sort of the verbs. So that's really cool. You can predict it, you can automate it in all sorts of way. It's fully secure. The barrier here, you can just later on read about it. But essentially, whatever comes inside the Vault as an application goes through what it's called a barrier. So it's a secure way of communication. Whatever Vault needs to talk to different components of itself inside, it goes securely encrypted inside what is called barrier. This is so it ensures essentially the integrity and security of the data inside the Vault, because Vault by its own needs to be secure. It provides security, but it needs to be secure anyway. There are token stores and policy store, which I'm going to talk a little bit later about. The thing is, everything, every communication with the Vault as a client standpoint of view, if it's a CLI, if it's a REST API call or whatever else mechanism, falls through a token-based communication. So that's something that is really important, and we need to know about it. And another thing is policy store. I'm going to discuss about this, but keep in mind at the moment that policy is to define a fine-grained application level specific. It's to not fully open the Vault cluster for the whole infrastructure, all the different pieces of infrastructure. We define policy for some specific part of the Vault usage. Essentially, what is really important for us is secret backends. There's all the different sort of the secret backends from the Vault that we need to define that, okay, I want to use, for example, database credential. I need to use database secret backend from the Vault, and so on. This will come up later. And essentially, we need to have a storage backend. Everything on Vault, essentially, at the end of the day, will be stored somewhere. It can be file system, it can be console, it can be etcd. There are all sorts of different storage backend which can be configured for a Vault server installation. I'm not going to talk about storage backends in this presentation because this is not a Vault presentation, but there are so many different tutorial and guides on which type of the storage backends you need to use. But essentially, you need to have an HA storage backend for the Vault. If your storage is gone, the whole Vault is not usable. That's basically an important piece that you need to keep in mind. So there are multiple authentication methods that you need to, when you want to use Vault, there are multiple different authentication. These two are basically the most important one in terms of the integration with the Cloudstack, but there are all sorts of different things. It is LDAP, AWS, AMI, GitHub, whatever. So you can define, I want to log in to Vault with my GitHub account or LDAP account or whatever. The app role here is particularly important for us or for any other application usage because you define a role for application and specifically narrow it down to the way that, okay, if someone asks that I want to use, I have this token for the app role ID, this is my app role ID, this is my password, I want to use Vault. Vault only specifically give access to specified role that defines somewhere else with the policy. So with this approach, we can have one Vault cluster for the whole organization. We are not giving out token to the clients of the Vault, developers, operations, whatever. We define roles, app roles, and give access them okay, you are on the Cloudstack team, this is your app role that you can use to talk to Vault, which has access to the Cloudstack related part of the Vault. You are on a dev team, this is your role that can have access to the, I don't know, MySQL part of the Vault backend. But at the end of the day, every type of authentication will be translated and eventually generates a token. The difference is, if you generate a token and give it out to your clients, Vault client essentially, it's up to you as a Vault admin to make them secure, to rotate them, to revoke them. But with the app role, you give your client a role ID and a secret ID, and it's the Vault job. Whenever it receives them, it generates a token with a provided TTL that you define in the policy that has access that is specifically generated token has, for example, life cycle of 15 seconds. That 15 seconds is more than enough for a Cloudstack to talk to Vault, to grab information, get it back, and that's it. It's done. It's not reusable again, that token. So if an attack happens in between and someone get a hold of that token, there is no TTL. The life cycle ends in 10 seconds later, 30 seconds later. So the use of token should not be done unless you have a very good reason that you want to use token-based authentication. I specifically put the best practice. This is I just got it from the official website of the Vault. So this basically says exactly what I told, that you should not use token unless you have a very good reason that you need to use the token for the sake of the authentication. Vault, essentially, then the secret engines of the Vault is the whole purpose of using the Vault. There are all sorts of different secret engines used for different purposes and defined in different things because they do different things. So you cannot mix and match them that, okay, I'm going to use secret engine, let's say key value, to store my database credential. You can do that, But the thing is, if you are using proper secret backend engine, Vault does something special on top of those secret engine that you don't need to manually and do a couple of more steps to get the end result. On that note, so the simplest form of the secret engine is key value. It's essentially you define a backend that you ask Vault, okay, this is my pair of key value items. Store them securely. And you can retrieve them later on with the same key value. The second one, which is one of the biggest integration point for the Cloudstack at the moment, is the PKI engine. It's it can act as a CA, as a certificate authority for your infrastructure. So it can generate, revokes certificate. You can define a root certificate, sign another certificate with that CA, root CA. You can define CRS, CLR to revoke the certificates, to define a revocation list of the IPs you want to block, all those kind of stuff that you would normally, for example, see in a Let's Encrypt infrastructure. You can have it in a smaller scale in a PKI backend engine. Databases is going to be used for database credentials. So let's say you have a application, web application that it needs to connect to Postgres or MySQL or whatever. Instead of defining your connection string to the database from the application point of view, you go ahead in the Vault and define a database backend engine and work it backward. So you define your database backend engine in the Vault. You point that to your application, and essentially what happens is that whenever you need a connection from your application, it sees that the connection string will be generated on the Vault side. It goes to Vault, asks about the connection. With the connection string defined in the Vault, it's going to generate a connection string. It can be a fixed user, random password, random users, random password, any combination. But the thing is, essentially, you don't need any particular user defined in your database for your application to be able to talk to your database. Everything is generated and keep track by the Vault. And you can, again, have a revocation, rotation, all those kind of stuff for all the backends anyway. Another one is SSH. It's going to, there are two different types of SSH backend engine. It's one of them is you can ask, you can integrate Vault with your infrastructure nodes. It means that if you want to SSH into a VM, you don't directly SSH into it. You can ask Vault, okay, what's the public key and private key that I already that I can use to SSH into the machine. Beforehand, you already configured this integration. So you would tell Vault that, okay, that's my machine, manage the SSH key configuration, the authorized keys and the public key of the users. Every time you try to log in, you ask Vault that what's the SS private key that I can use. It provides you one, and you directly use it on the machine that you want to log in. Another one, another type of the SSH engine is that it can provide you one-time password SSH. So it's not a fully key-based. Essentially, you try to SSH into something, it asks you for a password, but password keeps changing. It's only every time it's going to change. And for each time, you need to ask Vault, what's the current password to SSH to my machine? And for for that specific backend, instead of you use SSH as a command, Vault CLI actually implemented an SSH integrated SSH capability. So you use Vault CLI to SSH to some backend with some app role configuration, and at the same time it already knows about the password. It gives you one, you type the password and you SSH into the machine that you want to SSH into. There is another one that has been deprecated that originally it was doing the storing SSH key and generating the SSH key. So let's say in terms of the Cloudstack, we have all sorts of different SSH keys all over the place to be used either by the system or by the customer that using and sitting on top of the Cloudstack infrastructure. We could have stored them, the SSH key, or generate them with the vault or inside the vault. But recently they have found a serious problem and security issues with this specific storage backend, so they deprecate it and we dropped the implementation. So we need to revisit and rethink how do we want to proceed with this part of the integration with Cloudstack. Sorry. That we can manage and handle SSH key from the point of view of Cloudstack and store them or offload them to Vault. That's to be discussed in mailing list and GitHub to see what are the newer options. Transit is the one that I mentioned that Vault does not store the transit backend anywhere. You just ask Vault, this is my my string. It doesn't have to be a string. It can be a blob. You can give it a PDF. It's going to encrypt it and give you back the encrypted value. Whatever you need to encrypt on the fly, you give it to you need to create a transit backend engine on the Vault with correct combination of the key and the rotation and all this kind of stuff. Then you can start using that. You give it something, asks it to be encrypted. It's going to encrypt it with a key internal to the Vault. You receive it, you do whatever you want with it. Then when the time comes to decrypt it again, you give it back to the same backend engine. You don't need to provide anything else. All the required private key for the decryption is already sitting inside the Vault, so it's going to decrypt it and give it you back. The only thing that you need to consider with using the transit backend engine, it's that it's since the design was done that it can encrypt anything. It's not a string, as I mentioned. It can encrypt the blob as well, whatever. You need to base 64 whatever you are passing to it. Then Vault is going to encrypt the base 64 version, and when it decrypts, it's going to give you back the base 64 version of it. So it has, you need to have two extra steps on one extra step on each encryption and decryption, which is not a really big deal, and it's not really resource extensive for base 64ing something and then base 64 decoding something. But that's the only thing that you need to consider, that everything on the transit is base 64 encoded in and out. The other one is TOTP. It's time-based one-time password, the same as what Duo provides or what Google Authenticator provides. So you can ask Vault to generate a one-time password for a duration of the value that you provide for 10 seconds, 30 seconds, whatever. So then you can have some kind of a 2FA, two-factor authentication, build it yourself with the Vault instead of using G-Authenticator or Duo or whatever. Maybe in some cases it makes sense to use them, or maybe in some cases it doesn't make sense. Anyway, the functionality is there. It's fully working. It's up to the use case that you can find that, okay, I'm going to use the TOTP that Waltz provide. There are a bunch of more secret backend engines that I'm not going to mention them because either they're too specific or not really relevant to the Cloudstack integration. In the future it might, but not at the moment. We cannot foresee that. Yeah. So, in terms of the actual integration with the Cloudstack, the very first thing that we did is re-implementing the remote managed VPN. It was originally L2TP, but the IQv2 is going to replace L2TP because it's more secure, relatively faster than L2TP, and one more important thing, the L2TP on Cloudstack, when you define a VPC, you enable the remote managed VPN on top of that, and you are, let's say you are an organization, you are all behind one corporate firewall, and essentially everybody wants to work with that VPN, to connect to that VPN, to work on something, on some part of the infrastructure. With L2TP, you cannot connect to with more than one user from one IP to the VPN, or at least that's one of the main situation that we constantly kept running into. So, but with the IQVPN, this is not a case. You can have multiple users, even on single machine, connecting to the same VPN infrastructure, let alone everyone behind one corporate firewall. So these are the main reasons that we decided to replace L2TP with the IQv2. Not V1, because V1 had so many different flaws that V2 actually fixed almost all of them. So that's the decision that we made, and it's actually really working really well. The only things that needs to be done, this is the new configuration is added in the Cloudstack. So you only need to specify what type of the VPN you want to enable for this specific installation of the Cloudstack, and it works kind of like a switch over. You cannot have different type of VPN implementation per Cloudstack installation. It's either or. And essentially it needs to have a cutover going from the L2TP to IQv2. But let's say we decided to go and switch over IQv2 today. If you want to enable it, you need to recreate the VR for VPC for the configuration of the IQv2 to be applied on top of that. So as long as you don't destroy the VR of that specific VPC, it's not going to be, the IQv2 is not going to be implemented on that VR. So you can end up in a situation that IQv2 is enabled globally in the infrastructure, but there are still some part of the VPCs and VRs which still uses the L2TP. You need to just keep that in mind, that whenever you want to switch over, you need to recreate all those VRs wherever you see fit, and the maintenance schedules allows you to do that. As part of this, there are all sorts of different configuration were added. This is going to be again discussed in the mailing list, because the way we designed it, you can have Vault enabled. You can cut over from L2TP to IQv2 but not use Vault as a backend engine, because we already have existing CA framework inside the Cloudstack. Thanks to Rohit for his amazing job on that front, but it can be cut over with this configuration, the global setting as well, that we are going to use Vault as a backend engine for IPv2 VPN implementation. So you need to switch over to IPv2, then enable Vault as a backend engine. Then the rest of them are basically the configuration for how do you want to define your Vault setup. So, sorry, if this goes away, yeah. Okay, I cannot point to it. You need to provide the Vault URL endpoints. Oh, I should mention all these items in the third column are the default values. So there is no default URL for Vault. You need to provide it that that's the IP and port of the Vault that is listening to. The token I mentioned here, there are two different authentication methods. Either you can use a token globally, or you define your app role ID and secret ID. These are the pair that you need to, whenever you are going to generate a role ID, app role, you need to create a bunch of different steps in between. One of them is to create a secret ID, and the other one is to actually generate your role ID based on that secret ID. So you need to have both of them in these, the combination of the two will provide you access to authenticate yourself with the Vault. And these are actually mutually exclusive. If you, let's say you fill all the three of them, only token will be used because it takes precedence. So if you specifically want to not use token, you need to remember to leave it empty. Otherwise, it takes precedence of the app role mechanism. Then there are all sorts of the TTL that these are all Vault backend configuration. For the PKI, how long do you want your root certificate to live? How long you want your sign certificate to live? Also kind of the TTL that you can tweak based on your requirement that makes sense for your organization or infrastructure. Then this is you can change it or you can leave it. This is not really important. Whenever you want to sign a certificate with the Vault, you need to provide a role name to it. That role name is going to be used internally with the process of the generating a certificate. So you need to have a root certificate. It's going to use a role name. Don't confuse that with the app role. This is specifically PKI role name. So it can literally be anything. It only, whenever you generate your root certificate with whatever role name, Vault keeps track of it. So it's a one-time only per domain. So you can name it whatever. It's not going to be matter that much because it's going to be separated between the different sorts of the root CA on another level on top of that. It's not. It's going to be separated by the domain level on the Cloudstack itself. One of the most important part is the mount path. Everything in the Vault, all those secret backends will be mounted on a specific path. Most of them starts with the name of the engine. So if you want to work with the PKI backend engine, it starts with PKI whatever, or databases whatever. The only things that one of the best practices to work with Vault, essentially, to prevent collision between different mount points, is to essentially disable all the default ones. If you ask Vault, okay, I want to use PKI, it's automatically, as a default, it's going to mount it as a PKI /. And if you want to use another mount point for the PKI engine, so let's say PKI Cloudstack, since the mount point of the higher level already exists, it cannot mount another thing on top under it. So specifically, whenever you first install and configure Vault for the very first time, you can just go ahead and disable PKI root, the PKI default mount path, because to prevent collision. Then you are forced to specifically provide subsequent path for the mount point, such as PKI Cloudstack. Maybe another part of your organization want to use the same sort of the certificate generation for, I don't know, for your chef, Ansible, whatever. So instead of having them all falls under one specific path, you can separate them logically under different mount points. So this is the default value of PKI Cloudstack, but most of the time, all the Cloudstack installation, we don't have we don't have only one installation or one availability zone or one region. So it kind of makes sense to suffix that with more information. So PKI Cloudstack, Canada West, Quebec, whatever. Maybe you have 2 different data centers in Quebec. Maybe you have 2 different availability zones in each of those data centers in Quebec. So whatever makes sense to you for each installation, all these mount point is essentially to prevent collision between different installation of the Cloudstack from the Vault point of view. So just configure it as deep as you want, as specific as you want on different Cloudstack installation. And the first tool is just formatting, essentially. If you grab the certificate and you try to reverse parse it and get the metadata out of that certificate, it will show you that the description of the certificate, it has this plugin is constructing a specific format that is going to use the brand. So let's say you are in your own company, you give it your own name instead of a generic Cloudstack. So it's going to be used Cloudstack. This is the format, Cloudstack, whatever brand name you are going to use is going to be replaced here. VPN, name of the Cloudstack domain, then CA. So for a root Cloudstack domain generic installation, it becomes Cloudstack VPN root CA. For your domain, I don't know, cloudops.com, if it's another part of the a domain inside the Cloudstack, so this will become VPN cloudops.com CA. This gives the customer a sense of kind of ownership of the VPN, because the customer sees most probably if you are doing the multi-tenancy with the domain inside the Cloudstack, each of them sits in some kind of informative domain name. So in that case, you would, when they receive the certificates and download it to use them, essentially they would see that their own name in the title of the certificate. So it's some kind of maybe give them good feeling. So this is the one that I mentioned. So when you want to create the app role, you need to generate the app role, provide the certificate, provide the secret and secret ID to it. Essentially, then you generate the app role. At the same time, we can specify, use these policies on top of that app role to narrow down the access that a specific app role has inside the vault. This is the way to do it. These are the sample policies, the policies in the vault that there are another there are internal backend engine of its own with internal mount point of its own. We are not necessarily use them outside of the vault, but internally they are being used. So again, so let's say we have a vault cluster which is going to be used all over the place. Then we can define a suffix however we want to make this policy specific to some availability zone, region, whatever to prevent collision again. We tested a couple of different scenarios, and essentially we need to, for the PKI engine integration, we need to have these two mount points, because the first one is going to, oh, I should remember to mention, whatever, sorry, whatever name you are giving in this slide, whatever path, you need to replicate it and repeat it here. What happens is that in the vault that you are saying, this role should have access to PKI, Cloudstack, Quebec, DC1, let's say. So you define that in the configuration settings. At the same time, you are going to define the capability of the read and update for that specific mount point. What happens is, the first time that you ask as a client to enable remote managed VPNs, it talks to walls, okay, give me a root certificate and sign a certificate for that and give me back the information that I can pass it along to the user. The vault, do you see the mount point? No. So mount it for us, do whatever you need to do, then give it us back to prevent a manual operation from the operation team. Because otherwise, whenever you create a new domain inside the Cloudstack, you need to remember that go to vault and create a mount point for it. To prevent that and make everything automated, you need to give that a specific app role has access to mount something on a specific PKI / whatever. And after that, this is going to be used internally by Vault again to actually generate all the certificate, generate the root certificate, sign the certificate, revokes users or IPs from the certificate, handles and manage the CSR, all those kind of stuff. Everything happens under that backend engine, the PKI backend engine, and so everything needs to be done, read and update. So you need to, if you want to use the app role, you can give these two sample policies to the app role, and from the integration point of view, everything is done. The second integration point that we did is changing the behavior of how secret and hidden configuration from the global settings works. Essentially, up to now, everything was implemented, everything was encrypted and decrypted with the DB encryption utils that internally use the encryption of the PB with MD5 and DES, which is secure enough, which works. But the thing is, if for whatever reason the database is compromised, some attack happened and someone has access to our own database, what can be done is they can reverse engineer, because this is the Cloudstack is open source. Someone can easily find DB encryption util and see how we are encrypting the items inside the database, and it's Java-based encryption. So and decryption is just as easy. And the thing is, the chance of database being compromised is low, but the thing is, it could happen. But if we are using Vault as a backend engine, so we detect an attack is happened. The absolute only thing that we need to do is sealing the vault. Oh, I should have mentioned that earlier. So when the vault is sealed, it means it absolutely cannot do anything. You as a client talk to Vault, it doesn't do anything because it's literally sealed. Whenever you install the Vault as a first installation or second cluster or whatever, or after an attack, after maintenance, after a crash, you need to unseal it. Unseal means that Vault is now open for communication and connection with the client. So when an attack happens, the only thing you need to do is just go ahead and seal the Vault. That's it. They have the code in the GitHub repository, they have the database, everything is there. But let's say even if they are on the network, they cannot talk to Vault to unencrypt and to decrypt the whatever secret you have in your database. You need to unseal it to be able to talk to. So it gives another layer of security by some sense of the word, I guess. So it's in our opinion, it's a better implementation, as well as that it's going to offload the CPU usage for encryption and decryption, because these are CPU extensive. Maybe they are taking, I don't know, 10 milliseconds, but they are taking some time. Instead of putting the load on the management server itself to encrypt and then decrypt all those kind of values that we're reading and writing to the database, we can offload it to the Vault. There is another part for network latency and back and forth API calls, but generally it's way faster than, in the long run, it's way faster than leaving all those kind of computations sitting inside the management server itself, which has tons of other things to do anyway. For that, there's another config added, or leave it disabled to switch basically back and forth between the Vault configuration of the Vault encryption and decryption of the secret values, or leaving the Cloudstack management server itself encrypt and decrypt the values. This is going to use, as I mentioned, the transit. So the transit backend engine. So Vault doesn't store any of these anywhere except whatever Vault needs to store, namely the key of the key that is going to be used for encryption and the decryption. It's not going to be passed that anywhere. It's sitting inside the Vault itself. So you just give the value, it encrypts it, it gives you back, you store it in the database. The next time you need it, you query the same field in the database, you get the value, you give it back to the Vault, it decrypts it, then you use it somewhere else inside the Cloudstack logic down the road. So the same goes here. We have there is a discussion that we are going to maybe change the URL in a higher level to prevent duplicate, because right now we need to define URL for Vault endpoint twice for two different plugins, which points to the same Vault, which is redundant. But the token is the same thing, because one token rules them all. But the thing is, the app role and secret ID is specific, so these two are not redundant from the IKv2 plugin and the secure config plugin. But the Vault URL and token is the same, exact same thing that I mentioned before. Even these two, but for different app roles that you need to define for the transit backend engine. The same mount point prefix that you need to readjust or add more item at the end of it to make it absolutely unique per your whole infrastructure all over the board, whatever you have the infrastructure. This is the key name that when you want to use the transit as a backend engine, you need to provide a key name. That's the only the name of the key that's going to be generated by the vault internally and keep track of it. Then the next time you need to, when you want to decrypt the value, you just ask Vault that, okay, decrypt the value for me with that key you already have. So you can, this is just a sample name, you can give it whatever name you want. That name is going to be used for encryption and decryption of the values. And essentially you need to either enable it and disable it, as I mentioned earlier. And the same policies, samples that can be used for defining and generating the app role to connect to talk to transit backend engine. Again, the most important one is that these names per vault installation needs to be unique. So if you have multiple regions, zones installation, you need to have something at the suffix at the end of them, both the name of the policies and the actual mount point of the policies. So here and here. But essentially, these are the same thing as before. So these are up to now were implemented, but there are more integration points that make sense that to go towards that path. The first one is to actually offload the database credential management from the Cloudstack itself to the Vault. So right now, out of the box per installation, we have the Cloudstack which has two predefined user and password, root cloud and cloud. These are really good for dev environment or demo environment or maybe CI/CD pipeline. But for an actual production, we don't necessarily need to use root as a user, let alone root and cloud, or manually change the password of it. We can create an integration that whenever the management server starts, it goes and talks to Vault and receives its credential for the user. It can be absolutely anything. It actually starts with a Vault dash, if I remember correctly, db dash something. This is the actual name of the user. So the name of the user is really obfuscated, let alone the password. The password is even sits in the Vault itself. So it adds another layer of security because it's not predictable. The username is even not predictable to do a brute force attack or whatever. Another good integration point, in our opinion, is that to generate SSH key for system VM instead of with the Vault and send them back either directly to management server to be shipped to system VM, or the system VM itself can talk to Vault and ask for SSH key, because right now we are building them and injecting them locally in the management server that can be offloaded to a Vault installation. Another good point could be that we can use OTS, one-time password, for one-time SSH password for connecting to system VMs. Right now, the only thing that we can do, make the password of the system VMs randomized. So to add, to make them more secure, so it means that we enable that, we start the management server, then we don't know the password of the management server, the password of the system VMs itself. It is good, but why not we can make a one-time password instead of directly using, so we need to SSH into the hypervisor, then use a predefined key in the hypervisor to SSH into the system VM, but that can be done with a one-time password. It's because that private key sits forever in the hypervisor, but connecting to but asking for a one-time password is one time only for a limited amount of time, 10 seconds, 15 seconds, 1 minute, something like that. So even it's kind of more secure than randomizing password, maybe, because we are not using the private key which sits forever at somewhere. And any other thing that we might not be thinking of, because opening up the integration with Vault opens the whole door to so many different possibilities. We can offload so many things to the Vault that we might not have to think about it at the moment. Yeah. Yeah, sure. It was the last slide.
So, in regards to the API, you mentioned the Cloudstack CA framework. Is that implemented as well implemented as a plugin for the CA framework, or is it specific or useful to
So the question was, if I understand correctly, the Vault plugin, is it implemented for only CA or generally, correct? So as of now, I'm working on a PR to, and all these are going to be released in. We are aiming for 4.12 release. So it's going to sit alongside the CA framework inside the Cloudstack. So as I mentioned earlier, that you can switch between the two. You can enable IQ2, but ask not to use Vault. Use internal CA framework that we already have. Or instead of using that CA framework internally, use PKI backend engine of Vault to do all kind of the certificate CA work, essentially generating, signing, and returning back the certificate and CSR and CRL and everything.
Yeah, so you'd be able to use Vault, for example, for agent certificates, and everything else that uses the CA framework, or have you considered?
The integration wasn't done yet. Actually, we haven't started it at all, but potentially yes, because the way we implemented it, there is a service layer for it, and that you can inject it anywhere in the code. Sorry. That can be used for any part of the reason. So yeah, that's correct. It can be done. It needs to be discussed in mailing lists. If everybody is up for it, yeah. Because the whole point of it, the integration, processing, and basically encapsulation of the working with Vault is already implemented. So it's a matter of the when and where and how we use it inside the rest of the code base. Any other questions? Thank you.